in 10 kilowatt peak, right? This is what my capacity of plant, right? Power. 10 kilowatt peak is my capacity, right? After that, I need to optimize my tilt as well as azimuth, right? What is mean by tilt angle, right? What is mean by azimuth? That we should know it, right? A tilt angle is going to be how much you are going to tilt your panel to get maximum generation, right? That I will, after finishing this, I will show you, right? If I am tilting this much, then I can generate more energy. Here you can see loss with respect to optimum is minus 0.3, which means I am losing 0.3 power, 3 percentage of power when I am having this much tilt angle. I'm just going to optimize it now just by clicking show optimize. I am optimizing with respect to three things, which means I can optimize with respect to annual yearly yield as well as summer as well as winter, right? In summer,
Like,
your yeah, yeah. Is there any doubt? Right.
No, sir.
no, no,
Yeah,
no.
right. Yeah, if you can give three things, like annually I need to have this much energy, or else you can say my industry will run only in summer. I won't run my industry in my winter or something else. For that purpose, I need summer maximum energy. For that, what is the optimum tilt angle, right? That you can find, you can get the tilt angle by your running your PVsyst, right? Here I am just that is same as like winter. There will be some case winter going to be the load will be high. At that place you can, what is the optimum angle you can select, right? Now I am just giving annual. Right here you can see loss with respect to optimum is minus 0.3, right? I'm just going to optimize it, right? Just by changing my tilt angle, right? Yeah.
Hello.
If I'm, yeah, hello.
सर आई एम सो सॉरी सर बट सर जो सारी चीजें सर मतलब जो चल रही है सर कुछ समझ में नहीं आ रहा है सर.
I can't able to,
ये सूरज जहाँ सॉरी
चैट
yeah,
sorry
बॉक्स में डाला है,
yes
वो
yes
पढ़ लो.
actually he is asking for no
yeah,
whatever is going on he can't understand because of English, no, that's the reason.
okay,
And
uh,
सूरज
जी सर.
मैं
yeah,
यहाँ पर ना जितना हो सके मैं तो फटाफट नहीं कर सकता हूँ टाइप, तो मेरे पास जो भी आउटपुट यहाँ पर आ रहा है और जितना स्पीड से मतलब जितना हो सके मैं ट्रांसलेट करने की कोशिश कर रहा हूँ,
ठीक है सर. सर ठीक है सर
है
बट
ना?
मुझे
मैं
सर
बाद में क्लास के टाइम पे मैं आपको बताऊंगा, ठीक है,
थोड़ा स्लो में रहेंगे सर
जितना हो
समझ में
सके।
नहीं आएगा सर बहुत फास्ट चल रहा है सर
ओके
इसीलिए.
ओके
yeah,
ओके 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 एक्चुअली इज
yeah,
सेइंग इफ इट इज पॉसिबल टू
yeah,
like somewhat
yeah,
you can take a time and discuss, no, and it is going very fast
yeah,
as per his concern.
yeah. Okay, okay, I will go slow. Yeah, they have said pan India, so that I thought the English only the conveying thing. So that I said okay. Pan India means all over the
No
country. Yeah,
problem.
Yes,
यस सर
Yes,
यस सर.
yes, actually, yes. Actually,
yeah,
हर जगह से yes, everywhere is student are present, no? From
yeah,
south to north,
yeah.
everywhere. Yes.
That is why I'm going with English as well as they said. That is why I have accepted that invitation.
मैं सर साउथ
Yeah.
के लोगों के साथ काम किए हैं सर.
What?
yeah. Okay, sir, no issue.
Yeah.
Please
Yeah.
proceed. Please proceed.
Yeah. Right. Yeah. Yeah. Here you can see I'm just optimizing with respect to my tilt angle, right? With respect to optimum, I can the most thing is I need to reduce the losses, right? So reducing the losses, I'm just going with this tilt angle, right? This is the tilt angle which is given by my PV system, right? If I keeping this much, then my loss is going to be less, right? This is the thing we need to take care, right? This is how we need to take the tilt angle, right? I'm just giving next. After that, you need to provide what is the type of module you are going to use, right? All right, that is a thing. What is a module type? Whether it is going to be standard or translates, because of there will be some gap between there. These are all the panel manufacturers will say this is the technology which we are having. Depends on that. You need to choose it. What is a
Sir,
module type? Yeah, this is how you need to choose, right? And this is the technologies which we are using that panel, like monopoly, monocrystalline or polycrystalline or thin film, right? Monocrystalline is going to be your maximum energy generating, and it is most efficient than polycrystalline, right? And also its cost is going to be high, right? Because the energy production is high, right? So that cost is also is high.
yes, sir.
Yeah, right. And polycrystalline cost wise is less, as well as it is producing decent amount of energy, right? We can very well give what is the monopoly as monocrystalline or polycrystalline, depends on our requirement, right? These are
Uh,
all the types you can use. Yeah.
Hello, sir. What about bifacial?
Yeah,
There is also.
bifacial. Yeah, bifacial is upcoming technology that also we can give in this PVsyst. Now we are just seeing preliminary design. After the design, detailed design, you will can specify what is the bifacial you are using. Depends on that bifacial how much excess energy you are generating. That and all you can give it here. The PVsyst will give the result in report. Right. Yeah. If we know that thing in PVsyst, then I can directly go to my project design. Or else we just see this preliminary. You just try with this preliminary, and then if possible there is some other sessions also we can have. In that I will detailedly cover what is a project design. That right. Yeah. Now you can see here that is mounting dissipation. Depends on that mounting, my thing where I am going to place my panels, which is going to be like ground based or flat roof. Wherever I am going to place, that we need to specify here, right? That is what here I am just choosing with flat roof, right? And ventilation property, depends on your ventilation, your power generation will be there. uh, you should be aware of that. Like whatever the heat, it will not convert that into energy. Whatever the irradiance, that is going to be convert to energy, right? So don't think if solar is giving more heat, then our panel will produce more energy. Answer is no. It will convert only irradiance to our energy. If heat is high, actually our panel efficiency will come down. Whatever it is converting energy by irradiance, that conversion ratio will come down if your place or ambient temperature is high, right? So that what we will do some air circulation path for that panels, and we will keep some distance the air circulation for that one, right? If we giving that one, that can cool the ambient temperature. Depends on that ambient temperature, your energy will be optimally produced, right? Here you can see free air circulation and semi-integrated and fully insulated. If fully insulated means you are not providing any path for air, and it's fully insulated. Whatever the heat uh, falling on our panel, that going to be reduce your efficiency, right? Conversion efficiency, right? Right. I'm just going with free air circulation, right? I'm giving okay. Right. Now I have done with my preliminary design, right? And I'm just giving result. Yeah. Is there any doubt?
No, sir. You can proceed.
Yeah.
Sir, what was
Right.
what about azimuth?
Yeah. Hasimuth, you need to give by your whatever the angle you want to give from sun to, because you know what is the sun path. The sun is rising in the east and it's going to be west, right? This azimuth we always used to keep south. Why? Because if you keep your solar panel to east like this one, right, then sun will rise here from noon. From that noon you will generate maximum energy how much you will generate. After that evening the sun will go behind this panel, right? At that place
Yes, sir.
you can't able to make energy, right? If you keep near to west, from morning to noon you can't able to generate your power, right? And you can able to generate only half, utilize half of the day. So that what we will do, we will keep your panel towards south, right? If we are there in northern hemisphere, we will keep our panels towards south. Our India is in northern hemisphere, so that we are keeping our panels towards south. If it is southern hemisphere, then we need to give or keep our panels towards north, right? This is what
Yes.
azimuth. Yeah, yeah.
Yes, sir. Yes.
Yes, I thought I will take that in PPT because that's a concept, so that you can get that in detailed about that one. Uh, yeah, is that okay? Like if our session is going a little bit
Yes,
beyond our limit, right? We
No,
have
no
said
no,
problem,
it
sir.
is going good.
No
No
problem, sir.
problem, sir.
no problem, right? Yeah, fine. Because you should get at least whatever the thing you want, right? Just basics I will cover, then you can, we will wind up, right? Right, here you can see global horizon and global on tilted plane, right? Global horizontal means, consider your panel you are going to keep in horizontal with respect to our ground, which means you are not giving any tilt angle, just you are placing your panel on ground. There is no tilt angle. If I am keeping like that, how much energy I can make per day? That is the thing. If I have 10 kilowatt as a capacity, right? Here you can see this much kilowatt I can make, right, for per day, right? Per day I can make this much amount of energy if I am keeping horizontal only. We have tilted, right, 19 degree. Why we have tilted? Because this is the reason. You can see, by tilting your panel you can able to generate somewhat maximum power compared to your horizontal. This is where the tilt angle comes into picture, right? This is why our you can see whatever the solar plant which they are keeping, they will tilt the panel with respect to some degree, right? All right, that is the thing you need to observe here, right? This is the thing. And also you can see here investment cost and energy cost. Here actually we need to give exact cost how much it is going to be. Like here you can see here, yeah, I will go one by one. Here this is the irradiance plot. This is our irradiance plot. This much irradiance we can get if I am tilting my panel, right? And this is the graph, system output energy, how much energy I am getting as a output, right? This is the value going to speak whether your panel, whatever the capacity you are making in that place, it is feasible or not. This is going to be safe, right? If this much energy is okay for client, then your project will be executed, or else we need to look at, we can go for monocrystalline or something else that we need to look at here, right? This is a table, right? You can get whatever we have before seen, that is getting that as a table, right? Depends on month how much irradiance you are getting, right? All right. And here this is the cost. You can see here the cost is not exactly correct, right? Supporting cost will not be around this much and all for 10 kilowatt peak, right? This will be obviously very less. You can say in India, if you want to make 1 megawatt plant, for that it will around 3 crores to 4 crores it will cost, right? From that you can multiply the things, how much you can have the capacity. Obviously if your capacity is getting increased, there will be chance to reduce your rate, your cost, because you are going to buy more so that your cost may reduce, right? That details and all, if you go for market strategies, then you can very well get it, right? But we are now focusing on energy assessment only, how much energy we are generating, right? That is what we are seeing now. Here you can see this is the area, how much area I need if I need to keep 10 kilowatt uh, as a capacity, right? And how much energy I can make whole the year. This is going to be the thing. From that only you are going to get money from utility or something, right? Right.
Sir,
You can,
this is
yeah,
sir. This is actual area or a whole area?
actual area, which means only panel, how much
Okay, sir.
panels it's
Okay.
going to be, yeah, only panel area this is going to be. Yeah, because here you can see we didn't give any area with respect to how much area we are having. We are always speaking with our panel areas and panels related to our energy only, not really on ground areas. So it's not a thing. This is the area which required for only for panels. If you are keeping in ground, then it may be little bit increased, like 67 meter to something. How much gap you are going to give for each thing depends on that, your area will be changed, right? And here you can see this is the technology. If I am using polycrystalline, then I need this much area. If I am going with monocrystalline, then I can make this much energy with respect to 63 meter squared itself, right? That is the thing. Because monocrystalline going to be higher efficient than polycrystalline, right? Then you can see the difference. You can also see for thin film as well. Thin film nowadays most of the people in industry they are not using. You can go with this. You can even you can see the difference. Thin film means 100 meters squared. None of the industry is going for this much area for producing this much energy, right? They go with polycrystalline if cost is concerned. If energy is only the constraint, then they will go for monocrystalline, right? This is about your preliminary design. And what you can get output as from this preliminary design means, I can generate this much of energy with respect to this much of area, and I'm going to have this much of capacity by using monocrystalline panels for Andhra, wherever I have chosen the location. In that place, if I am keeping tilt angle as 19, this is going to be the result. This is what you can get from this preliminary design, right?
Yes, sir.
Yeah, yeah, I think it's understood, right?
Yes, sir. Okay.
Right, fine. Yeah, I have
Uh,
said, yeah, yeah.
Sorry to interrupt. How could we know that this is a optimal one with the
Yeah,
tilt angle and everything?
yeah, this is what we have designed now. Like with respect to losses, we have optimized our system, right? I think you have missed that one. And just here with respect to losses, you will keep your tilt angle as 0, as maximum as possible, right? This is how we can do. But yeah, you can see in reality they will not go for 20-degree tilt and all. They will go around what is the latitude they are having, they will go for that one. Why? Because if you keep more tilt angle, then your wind velocity, whatever at that place there will be wind velocity that may crack your panels and that may damage your panels. So that they concern about that one, and they will keep tilt angle as what they actually do, right? But even if you
Okay.
are going to install a, yeah, I think
Okay, sir.
someone,
Continue. Continue.
yeah, yeah. Even if you go for, in reality the people's urge to keep panels, at the time they don't even go take whatever the tilt angle suggested by engineer, they won't keep that and all. They just try to keep some tilt angle and they will finish the project. this is how reality is happening. But whatever, that is where the probability cases come into our PVsyst. Even in PVsyst you can see what is the probability I can generate energy, that and all. That is going to be advanced thing. I don't want to confuse you, right?
Okay, sir.
Yeah, you can go through that, you can able to get that. I just go through some PPTs, you can able to get. Yeah, this is the basic thing. PVsyst preliminary project, right? And grid connector, standalone pumping, these are all we have seen. And if you are going for project design, yeah, I think my screen is visible, right?
Yes, sir.
Yes,
Visible,
yes.
sir.
Yeah, right.
Yes, sir.
Yeah, right. Right. If you go for project design, same grid connected, same standalone, same pumping, but you will detailed design. That is the difference from preliminary as well as project, right? And these are all the solar types, like PV panels. By using PV panels, you can generate. And also SHS solar heating and cooling. That means you can go with heating and cooling of like cookers and all, you can see, right? That is some old generation people choose to have from solar production. And CSP is going to be concentrated solar power plant, which means whatever the solar irradiance falling on our earth, they will keep some tilt angle and they will make the all the solar irradiance to one place. That means they will keep like you can see that like a lens. In that lens we used to focus on one place, right? That is how they will focus one place, and they will keep water in that one, and the water will vaporize, and that will convert that into steam, and then they will run the turbine and they will produce energy. That is what CSP, right? And these are all the PV panel, how it is manufacturing: P type, N type, and poly, mono, and what are all the things, right? Yeah, it depends on that. Mono can see, you can see 17 to 20%. Nowadays this efficiency also increased. And here you can see polycrystalline 13 to 16% only, but thin film if you are going 4 to 12% only. uh, Mostly we can reject this one, thin film. No one going to use this one, right? And this is how the panels efficiency is there. And you can, because we are not going to connect only one panel here, we are going to connect multiple of panels. That is going to be series as well as parallel. If you series your panel, then your voltage will get increased. And if you parallel your panels, then your current will be increased. So that what is the power required for you, you will make the configuration, right? That is the thing. And there will be bypass diode will be there. If you see, if cloud is there, then that panel will be bypassed, right? That will be get out of service, and that from the diode it will pass. That is the thing, right? And this is the typical VA curve for panel. I think this and all you might studied in your engineering, right? Or else in school itself you may seen that one, right?
Yes, sir.
And these are, yeah, right, right. Yeah, this is the nameplate for that PV. In reality, this is how they will provide the nameplate. Here, this is the 260-watt panel, and power tolerance, which, because we said 260 watt, but it is not going to produce only 260 watts. It can capable of produce more than that or less than that. But nowadays, manufacturers providing only positive tolerance, which means it is going to produce energy from 260 to greater than 260, not going to less than 260. That is the assurity which is given by panel manufacturers. And this is the maximum current and maximum voltage, and short circuit current and short circuit voltage, and what are all the temperature level they have tested. That and all also they, this is a standard test condition: 1000 watt per meter square and 25 degrees Celsius. They will analyze this they will check this panel whether it is producing 260 watt or not. That is what they used to provide. Here I think you can see this is the standard test condition, right? 1000 watt per meter square and 25 degrees Celsius, and air mass is considered as 1.5. There is also one more test is there, that is nominal operating cell temperature. This is other type of testing our panel, but people tend to use standard condition only. The nominal operating cell temperature, there will be calculation will be little bit difficult, so people may not go for this one, right? And even you can see in panel they have mentioned only standard condition, not even they are speaking about nominal test conditions, right? Right.
Yes,
And
sir.
you can see, right, yeah, this is how your panels, this is going to be your solar cell, that will be going to be your module for the panel. And if you connect number of modules into series, that is going to be solar panel array, we can say, right? This is how it is going to be like this much of array is going to be one string, right? You can see, yeah, just I will, this is going to be your one string, right? This is going to be your one string, and number of string you have connected, that is going to be your array, right? This is how we can define, right? And there is also after that panel, you are going to have cabling and isolator and generator meter, right? Charge controller, batteries, inverter, right? What are all the equipment you are having? If you want, you can take screenshot of this one, right? It is going to be uh, how the flow of the solar cell to our electricity grid we are injecting, right? Right. Yeah. I think something. Yeah. Right. And these are all the latitude and longitude, which is basic understanding. Our globe is there. We are just utilizing latitude and longitude for accurately saying whether what is the location, right? That is where we are going with this. Yeah, here you can see the sun path for northern hemisphere. We are located in northern hemisphere. If we are in northern hemisphere, our sun path will be like that, right? Here mostly sun predominantly there in south side, so that only now you can say if where I'm, whether I can keep my panel facing south or whether I can keep panel southing north, facing north, which is feasible. The answer is going to be southern side, right? Because if I'm keeping my panel south side, then I can I can generate maximum power by absorbing my irradiance, right? It will be ulta for my southern hemisphere. Here I will place my panel towards north direction, right? Because the sun path predominantly going to be in north, right? So that I will keep my panels towards north, right? That is in Australia and all your southern hemisphere, right? On that place you need to place your panel towards north, right?
Yes, sir.
Right. Yeah. Here, these are all the model for tilt angles, tilt and azimuth. We can change this tilt and azimuth by using trackers, right? That is what they have specific. It's not running. You can see this is going to. Yeah, I think it's not playing. From here to here, if you change means that is going to be your azimuth. If you are changing your panel from this degree means, then your tilt angle is getting changed. I think from this one you can able to understand tilt angle and azimuth, right?
Yes, yes.
Yeah, right. These are as albedos and all, the somewhat deep concept. I will just say the what is albedo. This albedo is going to be determine your reflection, which means consider you have a ground, white ground, right? That white ground, what is going to be do means whatever the irradiance falling on your ground, that will be reflected back, right? But if you see black ground, black will absorb all the irradiance, right? Which means,
Yes, sir.
right, if you are having like white like surface, or else you can see They are saying values for albedos. Sand means it is going to be 0.15 to 0.4. Depends on this value, your reflection from the ground is going to be there. That reflected waves, reflected irradiance going to be fall on your panel, which means you can generate much more energy. Reflected diffused waves, from that also you can generate energy, right? This is the albedo for our country, right, or India, right? You can see here, and all over the world also it is there, right? You can, these are all you can get from internet itself. You try to see, go through that website whatever. And I also suggest some other websites that I will say after finishing this one, right? This is transposition factor, which means that is the thing. If I'm keeping the panel ground, then I'm losing some irradiance. If I'm keeping tilt, then I can absorb maximum solar irradiance. That is why I'm going for tilt angle. Not me, everyone going for tilt angle, right? Right. These are all about losses. And you can say here inverter is going to be two types. You will have centralized inverter, and you will have a string inverter. Depends on that, your connection will be there. That and all a little bit deep concept, I don't want to confuse you, right? That you can design this and all in project design. I suggest you to go through some YouTube videos, or even our company itself having some courses for that one. You try to see that and all, right? You can get a lot of knowledge, right? Yeah. Yeah, just I will show some other website which going to be useful for you, right? I will show that one, and I will come back to this one and how to read the report. You will see that, right? Solar GIS. This is the one of the website which you can get the real-time data, real-time irradiance from sun. That and all you can get from this one. For that you should have some accounts, right? That will be cost, but initial account you can create for free. That means you can get the trial version. After that you need to pay money, right? Here you can get most reliable data from that one, right? I'm just getting started. Prospect means then you can get, yeah, here you can pricing start 14 days free trial as well. If you are going to do any project, if you want real-time data, then you can go for this solar GIS, right? This will provide real-time data, as well as some other websites also there. Solcast, NREL, some other websites also there. From that also you can get your real-time data, right? Right. Then, yeah, now we will go for how to read the PVsyst report that we will see. This is one of my project which I have done, right? I just open this one. Here, whatever the orientation which is we have seen here, just we have seen fixed tilt in our preliminary design. But here you can see there is lot of options, right? You can very well go through this one and you can get knowledge about that one, right? Here I am just giving this one. Yeah, just I will go with fixed tilt project itself, right? Here I have used fixed tilt, right? And here you can see this is the system, which means here I am going to choose what is the panel I am going to use, as well as what is the inverter I am going to use, how much panel I am going to connect in series, as well as how much panel I am going to connect in parallel. That details and all you can get from here, right? This is what you need to design here. And what is the PNAM ratio, DC to AC conversion ratio, that and all you can see here. This may be like 1.2 to 1.3 is feasible range. People tend to say this one. Even 1 to 2 also there is there will be some things is that up to 2 PNAM ratio is 2 also also there. But if you keep that means, then you will be having clipping losses as well as overload losses. To reduce that one, we always tend to go with 1.2 to 1.3 as a p-norm ratio, which means DC to AC conversion ratio. Now here, for example, I will say this is 1000 kilowatt peak. Kilowatt peak is going to be DC capacity and 1000 is going to be AC capacity. Then DC by AC is going to be 1000, right? If I am going to have 850 kilowatt as AC output, then it is going to be like 1.2 or 1.3, depends on, right? I can go up to 1.3 to avoid overload losses. If I am going above, then it will have losses. Right? This is our system and detailed losses. The losses is the vast subject in our PV design, right? Here you can't able to measure what is the losses. Only ohmic losses you can measure. Other than that, we can't able to measure whatever the losses we are having. Soiling losses means you are keeping the panel in Rajasthan or something else. Even in Rajasthan, some solar plants are also there, right? In that, there will be more soil due to some wind blow. There will be the sun. There will be the sand will be deposit on our panel, so that there will be efficiency of conversion of the panel is getting reduced. These losses and all we may not know, so that we always tend to go with default values, right? These are all the losses which is available for the PVs, right? These are all a little bit vast. You need to read a lot on for understanding this and all, right? This is how you can design. I'm just running this simulation, right? We will see the report. Yes, this is the report first page. It consists of 8 pages, minimum 6 pages. If we are giving more details, then it is going to be around 8 pages. This is 1 megawatt plant, right? And I have given new simulation variant as a name, right? And shared on ground, and system power is going to be 1000 kilowatt peak. That means 1 megawatt. Where I am going to keep, that is Devapuram in India, right? Here, this is the first page. You can get what is the latitude and longitude of my site, right? This is what you can get, right? And what is the albedo for that place, that also you can get, and what is the site name that you can get here, and what is the meteo data I have used. I have said, right, meteo data that we can take from solar JS as well, some other softwares. Even PVsyst also have database that also I will show you, right? You just see this one and we will go for it, right? And this is fixed tilt. What is the tilt angle in my site I am having, right? That is going to be see here. And what is the shading? That is shading is going to be whatever the inter row shading, which means you are having one string. That means what I have shown in one image, that you can able to from solar cell to the cycle, that you can see that is going to be one row. From that, like consider you are standing in prayer, like in school days you will stand in prayer, right? One behind one, same as like that. Here also your panel will be placed one behind one, so that the first panel shading maybe fall on second panel, depends on sun path, so that we can include here, right? That is what the linear or whatever the shading which I am specifying here, depends on the module layer as well. I can define, right? That and all given here. And how much module I am going to use in this plant. At panels, it is going to be consist of 3861 panels is going to be there, and my total capacity is going to be 1000 kilowatt, right? Right. And this is about my inverter. How much inverter I am using? Only one inverter of 1 megawatt inverter, right? That is what I am using here. This is the thing you can get here, and in result you can see what is the produced energy over the year and what is the specific production, which means per kilowatt how much I am generating. That is the thing you can get from this specific production. And performance ratio, this performance ratio, people tend to speak a lot. If there is any plant, there will be what is a performance ratio. If performance ratio is greater than 75, then our system will be then that plant is good, like that the people used to say. Here we are getting around 77. That's not an thing. Yeah. And after that you can see what is the table of content. They have specified what are all the things available with respect to page number they have given, right? Here the same thing, tilt angle, azimuth, what is the thing, and whether how much shades is I have given. Near shading, how much I have given, that and all given here, right? And near shading, as I have took as a linear shading. This also you can change, like module, depends on module layout. I can change the shadings as well, right? And what is the PV module I'm using? Canadian Solar Inc. This is the manufacturer of my panel, and this is the model. And 260 watt peak is going to be my one single panel rating, right? I'm using this much panels, and nominal condition I can able to generate this much power. And how much modules in my string, that means parallel how much I have connected, in series how much panels I have connected. That is the thing they have given here. And this is about my inverter. This manufacturer is going to be generic, and model is going to be 1000 kilowatt, right? This is the thing you can get from here. You try to go through this one, you can get the same thing they will use it to provide, and how much area it is required, right? And total module, and nominal power, how much you can generate. And this is all about losses. That losses tab we have seen, right? Detailed losses. From that you can see what is the DC wiring loss, AC wiring loss, LED losses, right? String mismatch losses. You can see from this one as well, right? And also this is the thing you can design in your near shading. If you are giving near shading, then it is going to be there like that one. It will be given image like that. And this is the shading. Even though my sun is there, but I am not able to generate my power, that is shading will be there presenting in my system. That is the thing, right? This is the PNOM ratio, which is a graph for me, right? That is given in detail from January to December, that they are given here, right? PNOM ratio for the system. And this is the waterfall diagram or losses diagram. This much I can given if it is global irradiance, horizontal irradiance. Then after all the losses, how much power I can, auxiliary losses, energy injected to grid. Grid I can able to inject this much power only, 1655, but I can able to have this much energy production. After that there will be PV losses will be there, module losses will be there, array losses will be there, inverter losses will be there. All the losses are included, and then this much energy only I can able to give it to grid, right? This is the thing. And this is the daily input and output of the power which is injected to our grid, right? And this is the graph where I am giving maximum power to my grid. That is the graph of this one. All right, this is the thing. This is how you need to see the thing. And I will quickly go through the database. Here you can see geographical sites. In this geographical sites you can import whatever the country you want, right? Here I am giving new, right? I just give a new. It will take some time. It's getting time. Yeah. Here you can specify whatever the area you want, like Chennai or something else. You can give here. That site details will be imported to your PVsyst, right? This is the Chennai, right? Accept and select point. We can click this one, right? And here also you can see meteo details will be there. NASA data is there. PVGSI details are there. If you want to import NASA or meteo or even NREL, you can give here, right? That you should import. I have given Chennai, right? That Chennai, what is the latitude and longitude, you can see here, right? I'm just giving import. right. It is this is the global horizon irradiance data are imported from that NREL websites. Right? This is how you can import your details to our geographical site, and then you can utilize that to your design. That is what I have said, right? That I will convey. That is how you can give here. Right? Giving okay. If you want to save this file with this name, you can save. I'm just saving it. Right. This is how you can do that. You can import your database for that whatever the site you are having, that you can give it. Right. I think mostly I have covered what are all the things I want to convey. Yeah, is that clear? Yeah.
Yes,
Now
sir.
you can see.
Yes.
Yeah. Now you can see
Yes, sir.
Chennai database. Yeah. Chennai database is there in my database. My Chennai site is there in my database, right? I have imported NASA detail and it is there in my database. This you can use for preliminary design as well as your project design. This is going to be your project design, detailed design. This is what we have seen this 1 megawatt plant. I also shown you the detailed project as well, that you can also try it, right? If you found any difficulties, you can message me whenever. You can contact me with LinkedIn, right? From that
Okay,
you
sir.
can. Right. Yeah, I
Thank
think I
you.
have. Yeah, is it clear?
Yes, yes, and I must say कि
Yeah,
this session was very meaningful
yeah,
and um, also knowledgeable.
right.
And thanks again,
Yeah,
Surya ji,
yeah, right.
for presenting this um, like PVsyst that is really needs if we grow up with this field,
Yes,
no?
yes.
Yeah, this is very very important, and learners are very much get into this and. Uh, yes, thanks
Yes.
for
Yeah.
all of these sessions and this is what I'm going to say. Yes, thank you,
Thank you.
Surya ji. Thanks
Thank
for
you,
Yeah,
Surya
your
sir.
thank you.
presence.
Yeah.
Have a
Yes,
great day.
Can we
Thank
take
you,
a
sir.
virtual selfie? Yeah,
yes, sure,
sure.
sure.
Right. I
Yes,
request
camera.
every
Yes,
participant
please
to
camera
turn
on कर
on.
लीजिए.
Yeah.
Sorry.
Yeah. Yeah. Can we take that? Yeah. Photo. Right. Some background I have kept.
सर लीव कर
Right.
सकते हैं.
Yes, please,
Yeah.
please.
बाय सर.
Thanks for
Yeah. Thank you.
attending these
Thank you.
sessions, guys.
Yeah. Thank you.
Thank
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 you,
you,
you.
sir.
guys.
Thank you,
Right.
sir.
थैंक यू सर.
Yeah.
Thank you for the
Thank
valuable
you.
information and
Yeah.
everything.
थैंक यू सर.
Right. Right.
Bye bye.
Yeah. Bye. Right. Bye. Bye for everyone. Thank you for attending our session.
बाय बाय
Thank you.
सर.
Yeah.
Sir,
लेक्चर चालू होगा कल.
Yeah.
question question थे कुछ. I have some
Yeah.
question.
Yeah.
Sir,
Yeah.
what about the temperature factors? Can we adjust the parameter according to temperature?
Yeah. We can change that in our PV system. Depends on the temperature, how much energy which is able to generate. That also we can define in PV system.
Means
Yeah. Yeah.
like spacing between two panels and height above the
Yes.
ground.
Yes. That also you can give. That is what you can give in that near shading that I have shown some images, right? In that you can able to give that details. I suggest one more thing. All right. Yeah, let me share my screen. I'm not forcing you see this one. If you want, you can see this one. This is our website. Here you can take whatever the thing, whatever you are asking the doubt, right? Here you can see the PVsyst course, which is handled by me. This PVsyst 2. You can purchase from this one, or else we can see that one. I just saying you, if you want to know more about that one, you can very well see this one, and you can get more details about that one. Right? I'm just sharing that link with in chat. You can get that one. All right.
Okay, sir.
Right. In that, I detailedly cover everything that you can go through that one, and you can able to get. Right. Yeah. Yeah. Is that fine? Shall we wind up our session?
Yes, sir.
Yes.
Fine. All right.
Thank you, sir.
Yeah. Thank you. Thank you.